what, like it's not really perfect, but you can definitely can see that the inverted relationship on the transistor going on, and I do have like a gain of at least. Hey everyone, so it's been a long time since the last I made a video, and today I decided to make a video about how you can simulate, not simulate, or at least run a simulation on a NMOS transistor. It's going to be a very simple CS, like common source amplifier or a transistor, what do you want to say. These things are very confusing in ADS sometimes, so I kind of want to do it in a way that maybe makes sense, I guess. So let's start it. So first thing you have to do is you have a nice little place here that you can find components, and the first component that we would like to find, which is a NMOS model, not models, my bad, just an NMOS. So what you can do, you can just like directly write down MOSFET. And once you do it, you do have like a lot of options like MOSFET, NMOS, PMOS, which we're already using in PMOS. You can also use a generic model, but right now I want to use a non-linear model, which is a MOSFET, NMOS, so that I can work on threshold voltage, I can work on transconductance parameter and lambda, gamma, and some other CJ, HO, blah blah blah. So I'm just gonna use it. I'm gonna click it and I want to drag it around here. So once I have things here, as you can see that I have some kind of parameters around, right, but not all of these are here. So that's the reason you need to add a model. And if you don't have a model, which is a model MOSFET TM1, then you can't add other parameters and you can't really run the simulation. So you have to make sure that you have a model for it. And to find the model, all you have to do is you have to find a level 1 model. So there's many ways you can find it, but I might just want to type down level 1, and here you go. I can see it, level 1. You do have options of like a level 2 model, you have level 3 model, but for this video I guess it's maybe more easier for me to do a level 1 because I don't really have a lot of parameters to add. So I'm just going to use a model right down there. Okay, so the model you can see is it has plenty of things. Oh my gosh, hey, so you have plenty of things. It has like a CMOS, it has like a CGVO, then some CAPI, blah blah blah. This is pretty nice. We don't really need a lot of things for this simulation, at least for this one. All right, now we do have things. Now we have to build our transistor model, right? So first thing I'm gonna use is definitely I want to have a voltage source, which is pretty easy. You can just like go to go to any kind of sources, find a time domain, and get a DC here, and now add it like kind of maybe we want to rotate it so the plus is here, negative is on the other side. And you might want to change this to like 2.5 volt, and then you want to add a resistor value, definitely, right? So what you're gonna do, you're gonna just go to the lumped component, go to a resistor, and now we're gonna just choose a resistor here. And now 50 ohms is not really what I want. I want at least 12k. Super huge resistor, right? Or maybe you can also use 4.7 or anything you want. It's just a demonstration, so not everything gonna be perfect. But one of the most confusing part for me was like the input. How can I do the input? So I was having a huge pain in the neck by using. Maybe there's a way you can do it, but I don't know how to do it. Which was I was using. Where is it? Like, I just can't find it right now anymore. Probably somewhere like, yeah, like yes. I was trying to use the VAC. This guy. And I couldn't really make it work, and I was having a really hard time. But the one way I figured out that you just need a sine wave or anything like that. So what you can do is you can find a voltage sine wave, and there's many ways you can do, but I just want to see if I can find it from here. Seems like I can't. I can do a VT sine search. Here you go, VT sine. You have a step file, you can also use it. But I'm gonna go with the VT sine, which is a voltage source decaying sine wave. Now I'm just gonna use this here, by the way, I do have a bulk here, and I might just want to use it as a ground. I also want to connect my source to a ground. I don't really want to mess around a lot with that. Maybe just here at ground, and maybe just to make it more nicer, I want to put the ground on the other side here, so it looks kind of, you know, spaced around and nothing really looks too fancy or crazy. Maybe like go over here. Let's make it a little bit crappy intentionally. So let's connect to the ground here. Do connect to the input source here as well, and copy the ground and paste it to here as well. All right, seems like we have our model ready, but oh, we need a ground here as well. So let's just give it ground here as well, and once we do it, make sure you are connecting to the ground. Pretty simple, easy peasy. Well, we're not really done yet. We need to make some kind of configurations, right? So definitely I don't want to do a frequency of like a 1 gig for my dissimulation. I want to go with like a 1k hertz. Nothing really fancy. Well, there's another easy way to do it, just clicking this guy and choosing maybe like 1 kilohertz here like this. Then amplitude, I want to have like maybe like 100 millivolts. That's maybe fair. And also I definitely want a VDC too. So I'm thinking of like adding at least 1.5 as a threshold voltage. So I want to use a 1.7 volts so that I can turn on the transistor, right? I want my transistor to be turned on, and it's like in saturation mode. So I definitely want to have my threshold voltage less than what my VDS is, right? So definitely, here you go, turn it on as well. Seems like pretty good on this section. And now if you want to define your models, you can definitely do that. Like I can choose some length, model as 1e to the power 6, so it's like a what they call 1 micro, right? And I can choose a width of 20 micro, 20e, sorry, I made a mistake, sorry. I have to use as a 1e, right? And then I can do some kind of values here if I need. I don't really need it right now. One thing I can want to change is definitely the threshold voltage, right? So I want to do what? I want to do 1.5 because I used 1.7, so I want to use 1.5 here as a volt. You don't really have to maybe type down the volts, you just give to 1.5, and the KP is transconductance parameter. Maybe I'll just set it as a 80 micro, just a simulation, nothing really fancy. And gamma, not really, I don't want to use it. Maybe lambda 0.02 or 0.01, maybe just do 0.02. Now I have the model, I believe I do. So, but what I don't have is a simulator, so I need to use a transient simulator so that I can see the signal very well. I can see how the signal is getting amplified or anything crazy or whatever it is. I would just want to see it. So now let's just do a transient. Well, the thing is, I can just do from here. Sorry, I can just do from the simulation and transient here, and then I can just use it. So to see the signal of at least like 3 to 4 period, I definitely want to do 1 by my frequency or 1 by 1k, and that's how I can probably be fine with. If I just click it, what is it? I'd be probably fine with like a start time as. I think 0 is fine. I don't really care about the start time. I definitely do care about the stop time. I want it to be at least 5 millisecond at least, and then I want my max time step as 10 microsecond. Okay, so I want to see each of the nitty-gritty detail very well. Seems like I'm done, and I'm gonna run the simulation right now, and I'm gonna see what I really find, and let's just maybe go and see what happens. So right, I had a problem. So let's run it. It's saying no name is node where. Oh yes. So to see the values, you do need to name your net. So I'm gonna do V in here, and since you want to see your V out from this guy, so I kind of want to space things out a little bit, and maybe here. And now I want to see my V out from this source. So let's just give a name. It's giving me a little bit of pain, but let's just do this a little bit far. Let's have a name. Here we go. V out. Now I do have V out and V in, and I do have the NAT names very well. So once I do have the NAT names, now I can easily just turn on my simulation and see what happens. Here we go. Starting. Oh my gosh, here we go. I saw a nice graph, and I do see my V out as 2.399 volt. I do see my V in 1.6 volt, and there was like it's not really perfect, but you can definitely see that the inverted relationship on the transistor going on, and I do have like a gain of at least 1.8 or something, which you can verify later on. But I do also want to see the current, which I assume to be 16 micro at least. And now if I do want to see my current, all I can do is turn on the eye here. And if I do turn on the eye, which is like kind of a little bigger than what I really thought. So but it's definitely working at least, and you might have to change some of the parameter based on what you really need to use it, but it seems like doing the job that it needs to do. So thanks for watching the video, and hope to see you on the next. But by the way, if you change the resistor value to something different, definitely it's also going to change as well. All right, that's all I have for today, and have a great day, and thank you.